well, today the webinar is titled From Deep Sea to Tappen Z, a broad array of solutions from Teledyne Marine. This presentation is going to guide you through some of our more unique technology solutions and going to see us span a wide array of markets and applications. If you have any questions during the presentation, you can let us know by emailing us at info@teledynemarine.com. We may not be able to answer all those questions in real time, but we will get answers to you quickly or shortly thereafter, so feel free to use that. All right, so let's get started. I'm excited to welcome today's two presenters. Leading off will be Mike Reed, again, who's president of Teledyne Marine. Teledyne Marine is a group of companies primarily socializing in underwater applications with global headquarters in Daytona Beach. Marine Group was formed in 2015 with a focus of providing innovative solutions to the energy, defense, and oceanographic markets. Prior to this, Mr. Reed was president of Teledyne Oil and Gas, a group of Teledyne companies specializing in solutions for the oil and gas market. In 2001, Mr. Reed joined Ocean Design Inc., or ODI, as president and CEO. ODI is a global specialist in underwater interconnect solutions, primarily for the subsea energy market. In 2006, Teledyne acquired ODI. Prior to that, Mr. Reed worked for Raychem Corp. And ultimately serves as the Director of Research and Development of the Telecommunications and Energy Division. His career started in the UK and transitioned through Belgium. He currently lives in the US. He has a chemistry degree from the University of Aston in Birmingham, UK, and has completed executive education programs at Harvard and in the NC Business School in France. So after Mike speaks, we're going to be hearing from Dr. Pete Spain, who's joining us from California. Pete hails from the land down under, studied ocean physics at the Applied Physics Lab, University of Washington. He worked with new instruments for measuring ocean currents, and after a postdoc at SCRIPPS Institution of Oceanography, Pete joined RD Instruments in 1990. He's since worked in sales and marketing, where he has progressed from sales staff department to business unit management, and today is working in technical marketing. So Pete will be giving the bulk of the presentation here after Mike's introduction. All right, so I will now hand it over to both Mike and Pete. We're going to start off with Mike Reed.
Well, thanks, Dan. Good morning, everybody. We're glad you could join us. First of all, we hope everybody is safe out there in the world. We're sorry not to be in London this week, but we'll be back in Oceanology International in December, all being well. And it's my pleasure to open this webcast today, Deep Sea to the Tappen Z. And in addition, this month, we're launching the new Teledyne Marine Ocean book, covering 50 years of unique technology from deep space to subsea. First, let me introduce Teledyne Marine, a division of Teledyne Technologies. Teledyne Marine is a collection of 23 product brands operating as a cohesive entity representing the world's most comprehensive spectrum of technology, products, and system solutions to resolve harsh environment challenges on the ocean surface, undersea, on the deep ocean floor. We're truly a global organization with multiple manufacturing and service centers around the world, a sea of solutions, one joint solutions provider. Our passion runs deep. You can see on this slide, our 23 companies are aligned into market-facing segments. On the left-hand side, you can see all the interconnect and seismic connector and cable companies grouped together with a focus on scale and efficiencies. All the imaging and instruments companies promoting cross-functional synergies and innovation. And our third segment, the great portfolio of underwater and surface vehicles. A brief look at our history on this slide. Teledyne Marine, we've acquired 22 companies since 2005. Our strategy was to build a marine business through the acquisition of the leading technology companies that provide innovative solutions to the challenging underwater markets in the interconnect, seismic, instrument, imaging, and vehicle segments. The 23 acquisitions are now all integrated into one marine company. Next slide, please, Pete. We'll see on the next slide the markets that we serve. The offshore energy market, powering more than 500 deep water oil and gas fields from the North Sea to offshore Brazil. Our instruments are deployed in all the major ocean projects worldwide. Hydrography and navigation, we've supplied over products for over 100 years. The defense and security market, the gliders for the US Navy and over 50 years in support of the U.S. nuclear submarine fleet, water resources and civil engineering, more than 500 inland water projects, and now a new focus on marine construction. And finally, the emerging new markets such as aquaculture and fisheries. Next slide, please. Teledyne Marine serves a broad list of solutions to application challenges from topside to deep ocean across many markets. Our technology spans imaging, instruments, interconnect, seismic vehicle solutions, all designed to deliver actionable data to help make critical decisions. We use these great graphics to describe our journey with our customers, our business partners, and employees. And when you visit us and join us in London and Oceanology in December, you'll be able to see our solutions in action with multiple dockside demonstrations, as well as meeting the Teledyne experts from Marine. And this month, we're very excited to be launching the new Marine Ocean book, Exploring the Ocean, Understanding Our Impact. This is a fantastic publication. There are many diverse case studies from our experiences with working with customers on global challenges over the last 50 years. The publication complements the Teledyne Technology Space Book that was published last year, Exploring the Universe, Understanding Our Impact. And now we will look forward to Dr. Pete Spain explaining some of those case studies. Thank you very much.
Excellent. All right. Thank you very much, Mike. As Mike said, we'll now carry on to Dr. Pete, who's going to present solutions and of our interesting case studies about clients who've used Teledyne Marine products. These topics span the globe, quite literally, as you'll see. And if this session leaves you intrigued, you can learn more about it in this new book that Mike's talked about that we're going to be launching in London when you see us there. So don't miss out on that. All right, Pete, up to you.
Thank you, Dan. Good morning, ladies and gentlemen. Greetings from San Diego, California. Who knew that people came to work when it was dark? So, as Mike and Dan have mentioned, Teledyne Marine has published a collection of success stories that illustrate the broad array of applications served by our products. In fact, one recurring remark from early readers has been, I had no idea that Teledyne did some of those things. So today, my plan is to touch on a selection of these application stories with an emphasis on variety. And if this preview leaves you wanting to know more about the book, the stories, the applications, or the products of Teledyne Marine, I invite and encourage you to join us on the stand at Oceanology in the UK next December. So to start, let's look at a couple of impressive high-resolution images of the seabed collected by clients of Teledyne Reson using Seabed T-Series multi-beam echo sounders. At the left-hand side, you can see the coral reefs and floor of a coastal passage off Tortola in the British Virgin Islands. The data were part of a fisheries management and habitat mapping study conducted by the UK agency CFAS, the Centre for Environmental, Fisheries, Aquacultural Science. At the right-hand side, you can see a beautifully detailed seafloor image collected by the Irish survey company Hydromaster. They were working off the rugged coast of County Kerry in the southwest of Ireland. The region's striking terrain on land obviously continues under the sea. So, moving first to civil engineering. Inspecting the state of aging infrastructure is a widespread concern, especially difficult in murky waters. To meet this need, Teledyne Marine has been applying its established sonar technologies in new ways. The Tappen Bridge, located north of Manhattan, had been a vital thoroughfare for 6 decades, used by New York commuters for crossing the Hudson River. Replacing the bridge initiated the largest infrastructure project in the US. To improve the deconstruction operations in highly turbid water, Trimble and Measuretronics deployed a combined positioning and underwater imaging system that was based on Teledyne hardware and software. Subsurface imagery from a Teledyne Reson T20 multi-beam sonar was collected from a survey vessel and used to update a 3D surface model. Results were transferred in near real time to the machine fleet so that operators had recent views of their progress. Being able to monitor the subsurface situation and alter the disposition of heavy equipment not only saved time and money, but improved worksite safety for operators and for divers. The Great Pacific Garbage Patch is the largest accumulation of marine debris in the world. It's composed of swirling microplastics and other large pieces of trash. The patch merges trash from both sides of the ocean. Many objects are plastic and will only break down slowly over decades. The plastics also absorb pollutants, making them poisonous to marine life and fish. And that's obviously interfering with the ocean's food chain. In 2013, a foundation called the Ocean Cleanup was started by an 18-year-old in the Netherlands, Boyan Slat. This group now has a team of 70 working to apply advanced technology to purge this plastic debris from the ocean. In 2015, the Ocean Cleanup organized 30 vessels working simultaneously to map the Great Pacific Garbage Patch. They produced the first high-resolution map of the problem, but they could only estimate the true size of the garbage patch. In 2016, a different approach was tried. An aerial survey was made from a modified C-130 Hercules aircraft. They scanned thousands of square kilometers of the Pacific. In fact, every 5 minutes of the aerial survey was equivalent to the entire area that was covered by the ships in 2015. Ultimately, the debris field was found to be 16 times larger than researchers had thought. The aircraft carried an experimental array of high-tech sensors. They were used for scanning and classifying the debris field of plastics. Teledyne Optech operated a laser-based LiDAR system, an RGB camera system, and a shortwave infrared system. The cameras obviously recorded debris from above. They were complemented by the LiDAR, which penetrates to 80 meters. The data from the LiDAR provides a 3D view of the volume and depth of the debris field. In addition, Teledyne software fused this information to estimate both the size and density of the garbage patch, as well as the types of plastic present and their vertical extent. A detailed three-dimensional view was created to aid ongoing research. Moving now to the Indian Ocean. During 2019, Teledyne supported the NEKTON Foundation's pioneering marine missions titled First Descent, Indian Ocean. This exploration and research was conducted around Seychelles. It contributed to establishing a baseline on marine life and to examining patterns of connectivity between the marine fauna and flora through depth and around the islands. NEKTON is a UK not-for-profit research institute established in 2015 by Oliver Steeds. Its aim is to accelerate not only scientific understanding and conservation of the ocean, but also its sustainable development. The expedition worked around remote coral atolls. The team focused on surveying reef habitats below 10 meters depth down to 500 meters. They carried out a biological and chemical health check of the waters, as well as mapping the seafloor. Various products from Teledyne equipped NEKTON submersibles, enhanced their data collection and visualization, and supported their safe operation. High-definition cameras and high-intensity lights from Teledyne Bowtech aided the visual work that was conducted by NEKTON submersibles and ROVs. Seabed multi-beam echo sounders from Teledyne Reson, working with Teledyne PDS processing software, supplied high-resolution imagery of the seabed in near real time. And to ensure conditions were safe for subsea operations, water currents were continuously monitored by using the new Pinnacle current profiler from Teledyne RDI. Changing oceans again, moving to the Atlantic. Discussions about Earth's changing climate often turn to severe storms. Over the last decade, Slocum subsea gliders from Teledyne Web Research have been used to help with better forecasting of hurricanes and typhoons. The indicator of a tropical storm's devastating impact is its intensity. Improved understanding of intensity comes from knowing about subsurface water temperature along the storm's path. The energy that feeds a tropical storm comes from heat in the upper 50 meters of the ocean, specifically waters warmer than 79 degrees F or 26 C. Slocum gliders can take sustained ocean measurements of temperature, salinity, and other properties while they're descending and rising through the upper ocean. Equally important for storm monitoring, the gliders have both the control authority and endurance to intercept the storm track. For storm monitoring, Slocum gliders continually patrol a designated transect. In 2018, 30 gliders were deployed in 3 regions along the storm track in the tropical and western North Atlantic. The gliders surface periodically to send their measurements to storm forecasting centers. This subsea data is input to computer models that output predictions about a storm's intensity and trajectory. The accuracy of these computer predictions has improved due to the data from gliders. In fact, the US Navy often has 50 Teledyne gliders deployed worldwide, and they send data for ocean weather forecasting. Naval fleets and coast guards rely on knowledge of the ocean environment, from waves on the sea surface to what is on the seabed. Unmanned vehicles, both autonomous and remotely operated, are now seeing increased use in security and defense, from hydrographic data collection to explosive ordnance disposal. One example of this shift is the US Navy. It has a fleet of 200 gliders from Teledyne Web Research. After being launched from a single ship, the gliders can go their own way, navigating to different regions of interest. As well as other advantages, these vehicles offer reduced operational and logistical costs. These savings come from both carrying a variety of sensors on the one platform and from being able to efficiently collect large amounts of data. Other unmanned vehicles used in security and defense include portable low logistics vehicles. Teledyne Marine's lot includes a remotely operated USV, the Z-boat from Ocean Science, mini ROVs from Seabed, as well as the autonomous Gavia AUV. The Z-boat and mini ROVs are lightweight survey platforms that can be transported on a small aircraft or in a pickup truck. The Gavia AUV is composed of small modules designed for quick assembly or reconfiguration. Other Teledyne Marine products carried on these vehicles include inertial nav systems, high accuracy, high rate orientation systems, and multi-beam echo sounders. As well as hardware for the vehicles, Teledyne Marine also provides onboard data screening. And this too can be supplemented. Teledyne offers rapid shoreside data screening that uses artificial intelligence. In the energy sector, there is a constant need for regular inspection of seabed pipelines, end to end. Traditional inspections use boat-based or towed methods. Unhappily, they have some risk of collisions at rigs or subsea installations, and avoiding possible consequences can interrupt production at the platform. Some operators are using a Teledyne Gavia AUV to avoid these issues. They deploy these small-sized, man-portable vehicles outside the safety exclusion zone, and then the AUV follows the pipes right to the rig. The AUV can make engineering quality surveys. At the right-hand side, you can see the pinpoint positioning available with TRDI's DVLs, visible in black, compared with positioning with just acoustic beacons in red. With such steady motion and hovering of the AUV, operators can take full advantage of the high scan rates of the side scan, multi-beam, or cameras that are carried on the Gavia. In the oil and gas business, there is a push to automate offshore platforms. In particular, the majors want to monitor and control operations remotely. Plus, they want the connection to be resilient to hurricanes that move through the Gulf of Mexico. To this end, BP installed a fiberoptic network among its wells in the Gulf. Initially, 7 platforms were interconnected to each other and to land stations in Texas and Mississippi. The loop runs for 1,200 kilometers underwater, including depths greater than 2,000 meters. The design had to anticipate expansion. Today, 16 platforms are linked. As for network performance, the connection offers 100 gigabit per second data rates and less than 20 millisecond latency. An essential part of any network is making connections. For key locations throughout the subsea loop, Teledyne ODI had to engineer a new type of deep sea distribution unit that used wet mateable connectors for fiber optic communications. And those connections had to be made using ROVs. You'll have guessed the distribution unit needed to be robust to last many years. But in addition, its design had to be modular because it needed to allow for expansion of the comms network without any interruption of service. Another high-profile fiber optic network that's operating in the deep sea is the Regional Cabled Array of the U.S. Ocean Observatories Initiative. This array is located off the west coast of the U.S., specifically off the states of Washington and Oregon. Spread over thousands of kilometers, the network provides a real-time connection to various sites operating at depths from 200 to 3,000 meters and as far as 500 kilometers from the coast. More than 150 instruments are deployed. Some of these are winched 9 times each day from 200 meters depth to the surface. During these mechanical profiles, data being measured can be monitored in real time by someone back on the beach. Throughout the network, Teledyne ODI supplied deep-sea distribution units that used wet-matable connectors for fiber optic comms. Again, ROVs were used to make the connections. This network is planned to run for 25 years. Thus, the distribution units needed to be robust, and their design had to anticipate future expansion of the network. Another significant milestone in recent times was the 20th anniversary of the Argo program. Profiling float technology has transformed how the ocean is observed. This method was pioneered by scientists and engineers at Teledyne Web Research and SCRIPPS Institution of Oceanography. Profiling floats make periodic vertical cycles, typically every 10 days, by changing their volume to rise and sink. As they ascend through the water column, they measure temperature and salinity. The International Argo program has deployed fleets of these devices for sustained and widespread exploration of the global ocean. Many of these devices are the Autonomous Profiling Explorer floats, or APEX floats, supplied by Teledyne Web Research. In fact, Web has delivered over 10,000 profiling floats to the Argo program, the largest quantity from one supplier. There are about 4,000 floats in operation at once, each with an expected lifetime of about 4 years. They profile the upper 2,000 meters, though a new design reaches 6,000 meters. The floats have mostly sampled at latitudes less than 60 degrees. Each year, Argo floats gather about 120,000 profiles. About a year ago, the 2 millionth profile was measured. The resulting data sets form a rich resource for studying climate and ocean processes. The number of profiles made by Argo is nearly 4 times the total number that had been collected before Argo started 20 years ago. Before we go, I'll touch on observational programs that address Earth's climate system. Oceanographers often point to a large-scale system of currents in the North Atlantic called the meridional overturning circulation. It connects surface currents carrying heat poleward with cold deep currents returning equatorward. The deep circulation provides a buffer for Earth's increased heat and carbon dioxide that would otherwise reside in the atmosphere. Since the mid-1990s, US and Norwegian scientists have been using several cargo ships to monitor key transects in the North Atlantic. Their aim is to collect an observational basis for identifying any sustained changes in the ocean circulation. Each of their transects is traveled repeatedly by a commercial vessel that carries scientific instruments, notably ADCPs for profiling water currents to 800 meters depth. The second program is OSNAP, Overturning in the Subpolar North Atlantic program. This is an ongoing multi-year international research initiative. OSNAP includes many researchers with prior programs in the region. Their joint focus is ocean-wide transport of heat and fresh water as part of the global climate system. The work of OSNAP across the width of the Atlantic at high northern latitudes includes some really impressive mooring lines. And those mooring lines are equipped with a good many products from Teledyne Marine. From their first phase of observations, OSNAP scientists recently published unexpected findings. There were findings about the deep water supply, and those findings differed substantially from expectations that had been set by using computer models. And with that, I'll wrap my preview presentation of the broad array of applications served by products from Teledyne Marine. And at this point, I'm hoping there's at least one person besides me saying, I had no idea Teledyne did some of those things. And to reiterate, if this preview leaves you wanting to know more about the book, the stories, the applications, or the products of Teledyne Marine, I invite and encourage you to join us on the Teledyne Marine stand at Oceanology 2020, which is now scheduled to begin on Tuesday, December 1 at the Excel Centre in London. And with that, I'll say good morning or goodbye from San Diego. Over to you, Dan.
Excellent. All right, Pete. Well, thanks very much. Really, that was a great overview for everything we got going on right now. A lot of exciting things happening here, going on again in uncertain times that we're living in, but we all have a lot of good things to look forward to, and again, we're really excited to see everybody in December. In the meantime, I'll just say for us, it's right now we're conducting business, the best we can. We are very interested in speaking with people over the phone and via teleconferences like this. Look for more events like this over the next few weeks to months. Depending on the situation, we will be continuing to schedule online events and webcasts as much as we can to keep reaching out to people. If you're interested in meetings with any particular people, you can go to the same link on our website where you can request a meeting and we'll set something up. So through that virtual OI link that we have for this week, we'll keep something open so that if anybody wants to talk to a salesperson or a technical person, just go ahead and send us a message there and we'll make sure we get you in contact with somebody and someone will reach out. Again, we have Thursday's overview of new product introductions. So we'll go through about 6 different launches that we're going to be doing there. And again, you can register on that same link. And if you have questions or comments about this particular presentation for Pete or for Mike or for myself, feel free again to email us at info@teledynemarine.com and we'll make sure again somebody gets an answer to you or we get back to you. So that's about all for us today. I certainly want to thank everybody for coming out again and joining us. And I wish you all good health and stay safe. And we look forward to talking to you again soon. Thank you.